All right, guys, I think we've done this part several times. You can keep a running tally. You just need to declare a variable to hold your tally. And then you have a loop. And somehow you're getting a piece of data in, whether you're asking the user for it or if you're just adding a sequence of numbers. You add it to the tally. So if you want to add all the numbers between 0 and 10, you could do this, right? While number is less than or equal to 10, add that number to the tally. And when I'm calling tally, in this case, they named sum. Or you could ask the user for a score. What is test score? You know, type it in. Make them enter 10 test scores. That kind of thing. Or, you know, you could open a file. We haven't opened a file yet. We may skip the opening for files now because I'm in a hurry to get to functions, which we should already all know based on fundamentals, but we have to talk about it just a little bit anyways. Now, I think we've talked about sentinel values enough. We're familiar with that term, right? Sentinel values? Everybody say yeah? Okay. Okay, so sentinel value is just the one that you use to mark the end of data. Enter a score or -1. Enter a name or Q to quit. That kind of thing. Or tilde to quit. That would be better than Q, because what if somebody's name is Q? Like if their parents were Star Trek fans. Deciding which loop to use. The while loop iterates as long as a certain condition exits. You can use it for validating input. You could read a list of data terminated by a sentinel. So if you don't know how many pieces of data there are, the while loop's a good way to do it. The do while loop is just as good for this kind of stuff, except it always iterates at least one time. Whereas a while loop, if the setup is, you know, wrong or produces a value that doesn't let it into the while loop, it's just not going to, you know, enter the body of that code because it's a post test. The do while loop is a post test. It runs the body of the code at least once. And then lastly, if you have a definite list, like a range of values you want to run through, or an array of values that you want to run through, the for loop is the best syntax, right? Because it's the most concise. So the situations where the exact numbers of the elements or a predefined list array of data you have, that's what you want to use a for loop for. See if we can summarize those a little bit. Use a do loop if the body of the code of the loop must execute at least once. Use a for loop if you have a fixed number of iterations or a predefined list array of elements. Otherwise, use a while loop. Examples, they say that do loops are great for displaying menus. Okay. Honestly, there's nothing you could do with any one of these other loops that you couldn't do with a while loop, but you might use a while true. And remember that to get that to work, you have to remember what the break statement does. While true, you do something, you know. You read in something, and then if that value is the quit value, whatever, then you break. And break just bails out of the while loop. There's also another keyword, continue, which instead of breaking out of it, forces it to go back up to the top and do it again. Immediately. Doesn't matter how many lines of code there were underneath it. You know, if you had this, x++, and then you had continue, and then you had cout x, it's never going to print anything. Why? Because it'll never reach that statement. As soon as it hits continue, it jumps back up to the top. Whereas break forces it to go down to the bottom of the loop and exit it. Now the compiler might complain about that. I know the Java compiler wouldn't even let that run. It would say unreachable code. I think the C++ compiler would let you do that, but it would give you a warning about unreachable code. Why is it unreachable? There's no way to get to it. The continue forces it to come back up here to the top, so it'll never reach it. So just know what break versus continue do. Nested loops. Nested loop is a loop inside of a loop. Let's do one nested loop. Nested loops are good for two-dimensional arrays. We haven't hit two-dimensional arrays yet. I'm champing at the bit to go and get them. But we're going to do a nested loop. That's a loop inside of a loop. You have an outer loop and you have an inner loop. And you probably did this in fundamentals. The inner loop has to run and complete before the outer loop can iterate once again. So you have two loops. The inner loop goes over and over and over and over, and then it takes one iteration of the outer loop, and then the inner loop goes over and over and over again. So let's write a little program that uses a nested loop. So as usual, empty project, boilerplate, insert new file, all that kind of stuff. Source file, add, new item, C++ file, add. Alrighty, so here we go. Include ifstream, include string, using namespace, std, int main, system pause, return 0. All right. So here's what I want to do. I'm going to write a nested loop that uses two variables, x and y, and it prints out all the possible combinations of multiplying those two values together. So I think I'll use for statements. Those are my favorite loops. For int x is equal to 1, keep running while x is less than equal to 10, x plus plus. Now let's write a while, another loop inside that. This is the inner loop. I'm going to put a comment to the effect that this is the outer loop. The inner loop is going to have the same exact syntax, except it's going to be the variable y as its loop control variable. For int y is equal to 1. Y is less than equal to 10. Y plus plus. And that's the inner loop. And we're experienced enough to know not to put any semicolons after our loop statements. All right, let's see out x followed by a space, followed by, and when I say followed by, I mean arrow, arrow, y, followed by an equal sign, followed by x times y, followed by ENDL. That's a lot of followed bys. I'm going to break them out on several lines to make them perhaps easier to read. All right. I'm going to go ahead and run it. Then I'll leave the code back on the screen. It didn't do a darn thing. Neat. All righty.
Yeah, you have system pause first.
I forgot. Yeah. All right, you see that system pause? Move it down underneath the code above the return statement. My mistake. Thank you. All right. And I scroll up and down and eyeball what it's doing. You see the space here? The second thing I see outed. Make that an asterisk or the word times or multiplied by. So x, I'm going to put the word times there. I just changed the second element of the cout statement to that so that I get some better looking output. And sure, the word times is childish, but we all know what it means. Alrighty. So look at what it's doing. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. Go all the way down to 10. And then it starts over. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is right? All the way out to 2 times 10 is 20. And then 3 times 1 is 3. 3 times 2 is 6. All the way out to 3 times 10 is 30. 4 times 1 is 4. All the way out to 4 times 10. See? The inner loop variable y is getting iterated all the way from 1 to 10 before the outer loop ever increases by 1. So it's doing this part from beginning to end before it ever does the outer loop increment again. So that's a nested loop. You can use it to print out a matrix of values. You could use it to print out an array, a two-dimensional array. There's all sorts of ways that you can use nested loops. We sort of had a nested loop if we wrote our guessing game, and I don't recall if we did, to ask the user if they wished to repeat. Right? Because the inner loop was worried about whether they got the right guess or not, but the outer loop just wanted to know if they wanted to repeat the game. I don't recall if we wrote our guessing game like that. I've slipped since then. Alrighty. Anybody have typos they want help with? Alrighty. So a nested loop is a loop inside the body of another loop. In this case, this is the inner loop. This is the outer loop. Maybe they're printing out a tic-tac-toe board because it's got row 1, 2, and 3, and it's got columns 1, 2, and 3. So the inner loop repeats through every iteration for each repetition of the outer loop. So just as a homework assignment, and it's not hard to do this one, and if you had to Google it, I'd let you Google it. But ask the user for the number, or for the height and width of a rectangle. Then print the rectangle using asterisks. So for example, what is the height or the number of rows? 10. 5. What is the width? 3. And so what it's going to print? 1, 2, 3, 4, 5, or 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's 5 rows. So you're just going to do a nested loop. If you get stuck on it, Google it up, maybe in the textbook, send me a text message asking. This is the one time that I give you permission to go and Google it up. If you feel like saying number of rows and number of columns rather than height and width, and there's always more sophisticated ways of doing that than using a nested loop, but we'll live with that. I like that. Okay. Don't work on that right now. All right, using files for data storage. This is worth mentioning, but I'm going to want to come back to it later. What a file is via the mechanism that they're showing here is it's just another stream. Remember we have IO stream? You can also use file streams. What does that mean? Instead of CIN arrow to read in from a database, you can use a file arrow. Why did I say database? CIN arrow X to read into X. You could use file arrow X to read into X from a file. That's opening a file for reading. Or if you wanted to write back out to a file, you could use file, the other arrows, X, and that would write X back out to the file via the same mechanisms. You know, just using the arrow. So it makes it really easy to change your program from asking the user for data to reading that data from a file, or writing that data back out to a file. So we have this cute little loop here. Let's make that cute little loop write its table out to a file, a TXT file. Now this is already all nice and perfect, so I don't want to change it. So just copy your nested loop. You know, highlight all those lines. And paste it above the pause. So now we have two of them. Okay, there are some more includes we need to use in order to get this work. We have to include, if we're going to get input from a file, we have to use ifstream, input file stream. If we want to write data to a file, output file, we're going to have to # include ofstream. That's the one that I'm interested in doing here, because we're not asking for any data. Instead, we're displaying it. And I want to display that. I want to save it to a file. So I'm going to cheat and go to the PowerPoint rather than just do it by hand. Alrighty. So ifstream does input, ofstream does output, and if you're going to do both, you use fstream. Here's how you declare it. You use ifstream followed by a variable name. Now the variable name could be pretty much anything you wanted to, as long as it wasn't like a keyword or, you know, CIN. You wouldn't want to call it CIN. You could call it FIN, yeah, for file in, and then FOUT for file out. That might be fun. So to open the file, if it's an input file, infile.open, and you give it a file name, or outfile.open. Now this is assuming that that was your variable. Remember I just talked about using, instead of CIN, using FIN. We could do that. FIN and FOUT. Whatever makes it easy. Now the file name could be a fully qualified path, which means including the drive letter and all the directories and stuff like that. The output file will be created if necessary. The existing file will be erased first. Yeah, these methods of opening the file, if you're doing an output file, will blow away that file that was already there. There are other ways that you can do it that will append to the file. And the input file must exist for open to work. So I'm going to tack on some notes here. So that's the end of the homework assignment. ifstream, fin. ofstream, fout. fn.open, I want to read some input.txt. And I'm forgetting to put semicolons after everything. fout.open, and you notice I'm not actually typing this into Visual Studio, so unless you're typing your own notes, output.txt. Right? Now this, fin.open, file name has to already exist. And for this one, output.txt, output.txt will be erased if it exists. Do you remember in Python how you differentiated between reading and writing just by doing like that or that? Instead, we use two different class types. We use ifstream and ofstream. Alrighty, once you get your file, what do you do with it? You can check to see if it opened with an if statement. I don't particularly like this syntax, but what they've made it do is infile will return true if it's been opened, or it will return false if it has not been opened. And there are other syntaxes as well. There are methods you could call that would return true or not true, false, if it did not open. But that's good enough. Let's play with this stuff. Let's see if we can open an output file. So we're going to go back to our code. Now there's another include we need to add. So go up to the top and pound sign include, this is for, we're going to be writing data out, so ofstream. Pound sign include ofstream. Then go down between our two nested loops. Remember, we copied it. What's that? What's wrong with that? Cannot open source file ofstream.
I think it should just be that.
You think it's just fstream? All right. Just make it fstream rather than ofstream. All right. Scroll down between our two nested loops. See, I had that one and that one. We need to declare our ofstream. Ofstream, I'm going to call it fout, just like cout and cin. Today I'm fond of fout and fin. Now let's open the file. fout.open. Now there sure are a lot of ways you can open a file. And what do I mean by that? You notice that IntelliSense is offering 8 different choices of the open method. Whatever. Most of them are just overloads so that you can pass it different kinds of strings. ASCII strings, 16-bit strings. But anyways, okay. So what's our file name going to be? Why don't we declare our file name in a variable above it? So string file name is equal to, I'm just going to call it output.txt.
Oh, come on.
What'd you call it?
I said Thor.
Yeah, we could do that. Okay. So I'm going to do fout.open parentheses file name in parentheses like that. I'm not digging the name output.txt because I may have used that 20 times in other sample programs. So in my case, I'm going to change it to nested.txt. Nested because it's being produced by a nested loop. Nested.txt. I'm pretty sure I don't have a file name that already. All right, we want to make sure that that file exists. Why could it not exist? If we did an open, now since we're doing output, it doesn't depend upon that file already existing. But that doesn't mean that it will get to create the new file. What kind of thing could stop a file from being created? Just like if you were going to do a save from a Word document, how could you get an error message from a save?
That there's nothing there or corrupted file.
Right. What if there was no space on the drive? What if it was a bad path because you've specified the full path? What if it was an invalid drive letter? What if the directory was read-only? All of those reasons. So let's check to make sure it's open. If file name, if fout, but I want to make sure it's bad, not if it's good. So if not fout, let's print out an error message and then just return. Cout could not open space end quote arrow arrow and then the file name arrow arrow endl. I'm going to test it at this point, even though we're not actually writing to the file yet, just because I've made a bunch of changes. All right. It didn't blow up, although I didn't make it return. I could stick all this code inside of an else. That'd be the kind thing to do. You see this second set of nested loops? Tab that over so that we can put an else up at the top of it. Just grab that entire chunk of code, the second nested set of loops, tab it over so that we can then put else, open brace, delete the closed one that it automatically gives us, and then go down to the bottom and add a closed brace. And at this point, I've made enough changes that I want to make sure that it works for you. How could we force an error? What if I do z : // nested.txt? I just want to see it fail. See if that fails it. Could not open z nested.txt. Why? Because I don't have a z drive. Okay, I'm going to delete that. Notice I had to use 2 backslashes to get that to work. All right, so here's our code. Not that you can quite see it all. You can almost see it all. Just know that that says ofstream up at the top and that we have a closing brace down there. So to get this to write it out, I'm going to do fout, arrow, arrow, instead of cout. Now this is inside the second set of nested loops after I've opened the file. What if we want to print something up at the top, just saying what this file is? So after my else here, after that opening brace, I'm just going to fout, arrow, arrow. I'm going to say multiplication table. Not much of a table, is it? But anyways, /n, end quote, semicolon. So when I open the file, there'll be some kind of description up at the top of it. So that's all I did. My 2 changes to the code subsequent to this is to take that fout, put it there, and then to change the cout to an fout. Now when I run it, it ought to save it to a file. Now I didn't print a message out saying file created, which would have been nice, right? So maybe I'll go and I'll add a cout saying that the file was created. But let's see if I can find that file. I called mine nested.txt. See if you can find that file. It'll be somewhere in your project directory. So I'm going to click on the solution and do Open Folder in File Explorer from my Solution Explorer. And if I double click around, I'm going to see my txt file. Now if you don't have extensions enabled, you won't see the .txt, but it'll say text document here. All right, and there's my multiplication table. So maybe while we're at it, we ought to go ahead and read in the file that we just made. But we should close the file first. As soon as you're done writing to a file, come on, dock for me. I guess I'll just close you. Okay, fine, you're going away. Alrighty. As soon as you're done writing to the file, you should close it. Why? Because in some operating systems, if you still have the file open, you can't do anything else to it. You can't copy it to a flash drive. You can't back it up. You know, good backup software handles stuff like that. You know, but we don't want to keep that file locked and open. So as soon as we're done with our nested loop, we better close our file. fout.close. So just make sure it's lined up with your outer loop. Now the program, to our eyes, is going to behave exactly the same. Why? Because when it finally hits that return statement down at the bottom, as the program terminates, the operating system closes all files that it had open anyways. But you don't want to rely on that. You want to close the file as soon as you're done writing to it. All right, so, and let's write out a message. Let's display a message on the screen saying that the file was created. So either above the fout.close or maybe below it, I'm going to add one more thing, which is a cout. Cout, I'm not going to put this in quotes, file name, arrow, arrow, and then the quotes, space, created, and written to, \n. I almost don't want to do the reading part. We should do a reading part, but the homework I'm going to assign you does not involve reading. It just involves writing. So, you know, if I add the reading part, then somebody's going to think that they need to change their program in order to read from a file as well as write from it. So just know that when I tell your program that it has to write to a file, you don't need to suddenly go and modify it to read from the file as well. Alrighty. You know what would be nifty slick is if we took this and put it in its own function. If we cut and pasted all of this stuff and put it inside a function. But I'm going to leave it alone. You just understand that if we modularized it a bit by putting it in a function, then that'd be slicker. And the reason I say that is because, you know, then the main program's logic would be easier to read. Right now, our main is getting pretty messy. You know, we've got hundreds of lines of code in our main.
Can we just do that for science?
Yeah, let's do it. Let's do it. Okay, so what I want to do is starting from the string file name line and going all the way down to but not including the pause and return, cut that stuff. So starting from string file name, scroll all the way down or use your mouse wheel or whatever, go all the way down to but not including system pause and return 0, cut it. And what's our function going to be called? I don't know. I'm just going to declare it as void because we didn't make that return statement return a value. And I'm going to call it create, or I feel like giving it a long name, like write table to file, but you know, write underscore table underscore to underscore file. But I would like to be able to pass the file name in. But for now, I'm going to skip that. And then I'm just going to paste this inside the curly quotes that I just made, curly braces. Now I've declared this code, but I better call it, right? Because otherwise it's not going to do it anymore. You know, if I run it, but I never invoke that function, it's not going to, you know, run it. So down here in main, I'm going to call that method. Now I honestly can't remember that function name that I gave it. I shouldn't have called it a method. So I'm just going to highlight that function name and copy that, just because my memory is failing. I made too long of a function name. Now I'm going to scroll down to main, and I'm going to paste that either above or below my nested loop. Doesn't matter where. Write table to file, like that. Actually, I want it to be underneath. So I'm going to cut it. I'm going to go down and paste it above pause. Why? Because I want to see that message about creating the file as the last thing on the screen. I don't want to have to scroll up through 100 numbers in order to find it. All right. Nested.txt created and written to. I could go and validate that it was there again. I'm kind of trusting it at this point. I got that message. I'm feeling good. Okay, so when I give you your assignment, that doesn't mean you have to write a function in order to save for a file. You can put it inline in your code. This is just to demonstrate. Now the best thing to do here would be to make file name a parameter, because we're not going to always be writing out to a file called nested.txt, right? So I'm going to just comment that out. And I'm getting the idea that I ought to be doing a walkabout pretty soon. And I'm going to pass that in as an argument. So I need a string file name parameter in my write table to file. And I accidentally tagged on a 0. There. String file name. Now I need to go down and modify my method to pass in a file name. So where I call write table to file, just give it a file name. It doesn't have to be the same. Scroll down here, write table to file. I'm going to call it newfile.txt. Run it. And by the way, if you don't close your app after each time you run it, it may get to the point where it thinks it still has a file open and it won't let you open the file. Now since we're closing the file, as soon as we're done with it, we shouldn't hit that problem. But anyways, okay, newfile.txt created and written to. And if I went and I found my directory again, View, Solution Explorer, right-click, Open Folder and File Explorer, go into my code directory, I should see a newfile.txt, which has my table built into it. Remind me what I would need to do if I wanted to put this main function above this function write table to file rather than below it. Well, I'll show you what happens if I do that. Don't necessarily do this unless you're just really rocking the idea. But I'm going to cut my main function and paste it above write table to file, but it's no longer going to compile and run. The error is write table to file, identifier not found. Why is that? I see it right here, big as life. This is kind of like Python, but not Java. If you've taken Java. In Python, you had to define your functions before you could use them. In C, it's the same way, but you can get around that using a what? Maybe I haven't talked about it yet because we haven't hit the functions chapter. You use a prototype.
Yeah, you can talk about prototypes.
Okay. So what I'm going to do is I'm going to make a prototype for this function, which just involves copying the function name, going up near the top of the program underneath the using, pasting it, and putting a semicolon at the end. Now I can call it from anywhere. And if I put that in a header file, you know, I could make it so that multiple chunks of code could call it if I just did # include, you know, and then followed by my header file name. All right, made a lot of changes. Want to make sure everybody's got it going. I sort of feel like putting this nested code in its own function as well.
Just to make it cleaner, yeah.
Pardon me?
Just to make it cleaner.
You need a print?
No.
I'm sorry, my hearing is really bad. Pardon me?
Just to make it cleaner.
Yeah, to make it cleaner, I'm going to take this code as well and put it in its own function. So you see this nested loop here? I'm going to cut all of that and then just paste it to a file. Excuse me, to a function. Another void function. This one doesn't need a file name. So void print table, parentheses in parentheses, curly brace, and between the curly braces just paste that chunk of code. Not the nested loops from inside the write table, but the ones that were left in main. Now we would have to define a prototype for it, and we would have to invoke it. I'm going to do that. I'm going to invoke it here, print underscore table, parentheses in parentheses, semicolon. It's going to complain that that's an unidentified identifier not found, and so I need to declare a prototype for it as well. I'm going to just put the comment here that this is a prototype. All right, so I need a prototype. The prototype is the same thing as the function header, just ending in a semicolon. And it'd be nice if Python had this. Print underscore table, parentheses in parentheses, semicolon. Now my code should all hang together. My main is very short now, right? It's kind of cool. I actually probably want to reverse it. I want to call print table above write table to file, just because I like seeing that message. You know, file created is the very last thing in my output. You can never go wrong by putting your code into functions. That's a blanket statement that's probably completely unjustified. But you produce cleaner code, right? Our main is very short now. And then if you were trying to figure out what was wrong with what part of it, you're going, okay, I don't understand why it's not creating the file. Then you go, oh, I see. There's a function called write table to file, and you could scroll right down and spot where the problem was. All right. I haven't run it yet to make sure this absolutely works. Yeah, it works, but I really do want to reverse the order of it. So I'm going to take the print table call, cut it, and paste it above write table. That's the last change I'm going to make to this chunk of code. And I'm going to pause it.
Can you scroll down a little bit?
Sure. Which part? Which function? All right. Since we've already got it broken up into functions, let's go ahead and do a read file. So I'm going to declare this above main just for simplicity's sake. No, I'm not. let's go ahead and define our prototype. We know we need this, so let's define it anyways. Read underscore file, parentheses, in parentheses, semicolon. Oh, but let's give it a file name. So string space file name. So read underscore file, why are you giving me grief there? Parentheses, string space file name, in parentheses, semicolon. Now we're going to go and write a read file function. So instead of using ofstream, which outputs a file, we're going to use ifstream, which creates an input file stream. So I think I'm going to scroll down to the bottom underneath everything else and put that there. Did I call it read underscore file or just read file with that? Yep. Okay. So void, this is at the very bottom, read underscore file, string file name, and we need an if stream variable. So if stream, and I'm going to just call it fn, right, instead of cn. And I need to open my file. fin.open, parentheses, the file name that was passed in as an argument to this function. And the reason we're using functions before we've hit the chapter on it is because most of y'all have used functions with Python. Now we need to make sure that that file is open. If fin, or let's do if not fin, let's print out an error message and return. Cout could not open space, end quote, arrow arrow, file name, arrow arrow, ndl. Or we could say file does not exist or something, but that's good enough. And then let's return. We're done if we can't open the file. Now we want to read from it. And I'm going to go back to the PowerPoint and make sure that I do it exactly like they demonstrate, rather than running off and doing something else. Here's their function for checking to see if the file is open. Instead of if not fin, I could remake this say if parentheses fin.fail, parentheses, in parentheses. Sounds like I'm talking about the plot to Last Jedi. So you could do it either way. I like fin.fail. I like calling functions rather than just using if followed by the variable name, because this is what most languages would do to do it. It's C++ lets you override operators to let you do strange things. Okay. So anyways, let's go look to see what they do next. You can read in one piece of data like that. That would read in one piece of data. Or we could read in the entire piece of data. Let's see what happens if we do it like this. Let's create a string. And then let's try to read into it using that syntax, except it's going to say fin rather than input file. So here I'm going to make a string, and I'm just going to call it data. And then while, parentheses, fin, arrow, arrow, data, while we have data in the file, let's just write it back out using cout. Cout, arrow, arrow, reading, space, end quote, arrow, arrow, followed by our data, our line of data, arrow, arrow, endl. Then we should close our file. fin.close. Now I never called the function, so it's not going to work. I need to go back up in main and actually invoke my function, but just make sure it compiles. Compiles first. Do a build, rebuild, right? Just make sure you don't get any errors. Now I'm going to scroll up and modify main to call this read file function. Maybe right here. After, nope, that's not even in main. All the way up in main. Before our pause statement. Let's read our file. Read underscore file, and let's give it a file name. I'm going to use new file.txt because hopefully it's there because I just created it. Let's see what happens. All right, look what it did. It's not reading it in line by line. It's reading in every word, every token that's entered into it. You see that? Reading a 1, reading an equal, reading a 5, the word times, the number 2 equals 10, 5 times 3 equals 15, 5 times 4 equals 20. So it's pulling out all the data chunk by chunk, just like CIN does, right? If you type in 3 things, but you use CIN to read into a variable, it only gets the first thing. Then you have to use CIN, again to get the second bit of data, and you have to use CIN error a third time to get the third. Okay, I think that's a good enough example for now because we're not concentrating on reading. But that's the syntax. You open the file, and then you use, this is known as a file handle, and then we're storing that in a variable. What we need to do this a little bit better would be to create a formatted data file that had a set of numbers that we wanted added together. Something like that. This is just opening a file and reading from it and not doing anything with the data. All right. Wave your hand if you're getting syntax errors or it's not running. We all good?
How do we fix the reading thing? Reading.
Okay. Pardon me? But you haven't defined prototypes, so you can leave me in the That's not good. That's one defined prototype, but they're not using you just don't have to put a statement. So it's a wonderful, but if that's where you're right there. Yeah, you can't make it clear that far. I have the space,
Yeah. Oh, that's what. Oh, that's all. That's the word.
reading the whole file, element by element. Sure. All right, you're going to want to do the Chapter 5 quiz. We're done with Chapter 5. And we could scroll through and look a little bit more. I don't think there's anything else. Letting the user specify a file name. So we can pass a string as an argument to a file streams object. Notice it says in C++ 11. That means any version of C++ after 2011 will let you do exactly what we did, which is open a file like that. If not, you would have to extract what's known as the C string from it. So file name dot C string like that, but we're not going to mess with that. It works for us. It's going to work probably with every version of C++ you use, but if we got an error there, and I had somebody who, instead of using Visual Studio, was using a different compiler, and it wasn't up to the 2011 standard, and so we had to make that change. guess it's worth talking about what a C string is. In olden days, your strings look like this. You had some letters, and then at the last space was something called a null, which I'm going to indicate by a /0. And so if you did this, if that was your string and A happened to contain that, then if you printed out A subscript 0, it would print out an A. But it would be a character, so I'm going to use a single quote. If you did A subscript 1, it'd print out a B. Come on. If you did A subscript 2, it would print out a C. You recognize what this is, right? Because I did an array last time or the time before, and you've done lists before. And an A subscript 3 would be that null, which is just really a 0, like that. It doesn't have a value, it's got a 0. And then A subscript 4 would be reading past the end of the string, which is bad. So this is what's known as a C underscore string, also known as a 0 or null terminated character array. Now that's getting into old C terminology, but it's a character array. It's a character array that's got 3 characters in it, terminated by a 0. And /0 is just an escape sequence that means end of string. Just like \n means new line and \t means tab. So if we had to get that out, we could do, you know, something like filename.c underscore string, and it would extract that data in the form of a character array like that, so that you could interface with functions that don't accept the fancy string class. All right, the reason I mentioned this is that we're going to get to arrays, but not now. Now what we're going to do is go to the next chapter. Oh, breaking and continuing a loop. I thought we were done. We know what the break statement does. Have we used it before? Somebody nod your head yes or no.
Yes, break.
Right. So, you know, if you're inside of a while true loop, you could use break to bail out of it. And if you use a continue, it's going to exit the loop and go, well, didn't I demonstrate that up at... Yeah, okay. All right, sorry. Very well, we're done. Homework over this file business. You're going to modify your BMR program, assuming you wrote one. Remember that? The basal metabolic rate that told you how many calories you needed? You're going to rewrite that so that it saves its output to a file rather than displaying it on screen. If you feel like displaying it on the screen as well, that's totally fine as well. So it's really a pretty short assignment if you remember how to use an ofstream, how you declare an ofstream, and how you send data to it. So revise your BMR assignment to save its output to a file. It should ask the user for a file name. Now I didn't ask the user for the file name. I just hard-coded it, you know, to output.txt or whatever it was. So it should ask the user for a file name. It should perform all the BMR calculations, and then the results should be saved to that file. Use an ofstream to write to the file. You don't have to turn around and read the file back in like we did with our read functions. Just write it out, close it, and you're done. And I want to be able to go in and, you know, run it, make sure it doesn't produce any errors, go and look in your project directory, find the txt file that you saved it to, make sure it's got some good output, and then, you know, then upload your project. So that's that homework. Any questions over that?
Is that the same homework you told us in the beginning? Or is that different?
So rectangle asterisks.
We've got 2 homework assignments coming up. We've got the rectangle one and we've got this one. Different ideas. The rectangle one is just to do a nested loop. And I'm not telling you how to do that. You know, how to print the rectangle. Either figure it out or Google it up. You'll find a good solution for it. And if you get stuck, ask me for help. I can give you pseudocode or something. Thanks for reminding me. I might not have uploaded the rectangle assignment if you hadn't reminded me. And you're going, why'd you remind me, man? All right, so let's go to the next thing. Oh, I need to move this up to the proper directory. All right. While we're at it, let's make a Dropbox for today's work. M. All right, I want to end it now rather than lecture for a whole 5 minutes. And I know that there are questions over homework, so why don't we go ahead and stop. There's a Dropbox, hopefully. Dropbox M. Go ahead and put your CPP file or your whole project in from today there. If you need to talk about homework, hang out. Otherwise, I'll see y'all on Thursday. Note to myself, upload the rectangle homework.